We have discussed already that there is positive and negative charge in the n-type and p-type region in the form of ionized dopant atoms. The charge density can be written as from the Poisson equation we can write we will first find the value of electric field for p-type region. Integrating the equation, we will get electric field to be equal to, here C1 is a constant of integration. We know that the electric field is 0 outside the depletion region. Therefore, we can find the value of constant of integration C1 by putting the value of electric field equal to 0 at the boundary of the p-type region. And by doing so, we will get the value of C1 to be equal to, therefore, the net electric field equation will come out like this. Similarly, we can find the electric field for the n-type region. Here C2 is another constant of integration, and we can find the value of constant of integration C2 by similar manner the way we find the value of C1. Therefore, we will get the electric field for the n-type region to be equal to, these two equations together provide the intensity of electric field present in the depletion region. If you try to plot a rough diagram of the electric field intensity with distance x, then we will get a rough plot like this. By looking at the graph, you can see that maximum strength of the electric field occurs at the meteorological junction. Putting the value of x is equal to 0, we can find the maximum electric field intensity. Even though we have two different values of electric field at the meteorological junction, but since electric field at a point can have only one value, therefore both these values are equal. By equating these two equations, we can find a very important relation. I have already derived this expression earlier. This is just another way of deriving it. I hope you understood the derivation as it is quite important.